Hello, today we are going to be looking at the periodic table. I will remind you that the very first version of the periodic table was created in 1869 year by the Russian scientist Dmitry Ivanovich Mendeleev. By that time, there were various attempts to classify the chemical elements, but managed to embody it in the form of a table on which we are working. And nowadays, only Russian scientist Mendeleev managed to do it. I must tell you that this event was preceded by very many attempts to make tables by various scientists, such as Newlands, including scientists Lotte Meyer and others, but their attempts did not result in such a large-scale project as the periodic table. The original version of the table created by Mendeleev included 7 groups of elements and not all of them, as now there are 7 periods, but there were fewer periods because not all the chemical elements in each of the periods. Therefore, the original table had only 7 groups, but the 8th group, these are inert gases, by this time had not yet been discovered. But Mendeleev, creating his table, did not know the structure of the atom, and therefore the chemical elements they were distributed in the order of increasing atomic masses, as well as valence, which the elements at that time was known. This scene the periodic law appeared, which allowed to arrange the elements exactly in a certain sequence, but the ordinal number, to which Mendeleev at first did not attach much importance, initially the meaning of this number was not known, and therefore each element had an ordinal number, but some great meaning in this number did not put. Then when the first version of the table was created, the short version of the table as we call it, there were permutations in it, which were made including Mendeleev. And afterwards, when the table appeared in print, it was published in various scientific journals. The table received a certain form. But once again, this table had fewer periods and fewer groups than we have now. That variant of the table, which you see in front of you now, is called the half-length variant. It was created later in, and this version has a correspondingly larger number of groups. There is also a long version of the table, which is not widely used, and it includes a group of lanthanides and actinoids in their places. Usually these families of lanthanides and actinoids are brought down the periodic table. So how does a modern table work, and what elements does it consist of, and what families does it contain? So there is a division by periods. Please note that the period numbers are usually written on the left side, and they are depicted, of course, in Arabic numerals, as you can see here. My table shows the 5 periods in full, and the 6th and 7th in this case are outlined. You can see the elements of these periods by looking at the periodic table, which you probably have. Now, how many groups are there in this half-length version of the table? In this case, the groups are respectively 18. And please see that these groups are also numbered with Arabic numerals. In the original version that Mendeleev had, the numbers of the groups were shown in Roman numerals and were shown with the Roman numeral with the designation of the subgroup. First A group, first B group, and so on. And now in this version of the table, it is usually not signed, but to know where here is the main and where is the side subgroup is quite easy, and you can orient yourself in this. So let's see what elements the periodic table consists of. Hydrogen has the first ordinal number. It is the lightest chemical element in the Mendeleev table. It is followed by helium. Helium was not discovered immediately and was not yet discovered in Mendeleev's time. Then the second period starts with lithium and ends with neon. The third period starts with sodium and ends with argon. The fourth begins with potassium and ends with krypton. The fifth from rubidium and ends with xenon. The sixth period begins with cesium and ends respectively with rhodon. And the seventh period begins with the element France and ends with 118th. This is so far the last element in the Mendeleev table called agonizone. Now how the table is arranged next. The first group of elements are the elements that have gotten, I would say so, retained their name since the days of alchemy, and these elements are called alkali metals. This family has this name because of the fact that these elements are active and form a class of base substances called alkalis. In addition to being alkali metals, they are very light metals. But I must say that hydrogen, which is in the same group, does not belong to the alkali metals. Hydrogen is its own element. It is privileged to have this element, which is its own family of hydrogen. The second group of elements of the family are called alkaline earth metals. This group received this name because of the fact that they also form alkalis. But in the days of alchemy, earths were called oxides. So if translated into language, it turns out to be metals. They're oxides forming alkalis. These metals are not light. They tend to be harder than alkali metals, but they are quite active. Other than that, this is the block you see, S. And the second group are the S elements, the S block. Then, in the second period, starting with boron and ending with neon, are the elements that are called nonmetals. The nonmetals are almost all of them, except for the element boron, and I'll talk about that family a little later. In the third period, after sodium and magnesium, which have S elements of metal, comes aluminum and dorgon. But aluminum is a metal, but silicon belongs to the same family as boron. All the other elements are nonmetals and so on. In the fourth period, from scandium to zinc, in the fourth period, it's the elements that make up what's known as the D block, the D elements. Then there are again, starting with gallium and up to krypton. These are the elements that some of them are still metals, but arsenic belongs to the family, as does silicon boron. This is the family that we'll call a little later. Selenium, bromine, and krypton are nonmetals. In the fifth period, the first two are again metals S elements. From yttrium to cadmium are D elements, and from indium to xenon are elements which, like the elements of this block as a whole, belong to the P elements. As the elements of this block as a whole are P elements. Below, in the sixth period and in the seventh period, appear the lanthanoids and actinoids. These elements make up block F elements, once again I repeat, and in the short and in the half-long variant, these elements are carried below under the seventh period. Now, what else are these families called? The point is that the elements of the 18th group, these elements were not originally included in the table because they were discovered by Ramsay afterwards, and they're called the noble gases. And these elements are inert gases. They don't react with almost anything except for a few compounds, not more than 150 of them, and most of these compounds are halogens or oxygen. Then the 17th group, these are the halogens. They are the most active among the nonmetals, and the king among the nonmetals is fluorine. In addition, there is another 16th group, which is called the family of chalcogenes. Chalcogenes in translation from Latin mean copper ores forming, but halogens mean salts giving birth. The other families do not have any special names. They have not been preserved. Now let's return to this dividing line which separated boron, silicon, arsenic body. These elements are called metalloids. Such division of the periodic table, including the elements, was proposed at one time by the French scientist Lavoisier. Metalloids are elements that look like metals, and that is why they are called so. Metalloids are boron, silicon, arsenic, tellurium, and accordingly there are elements located below. Now let us see how the metals are lined up. Here you can see I've got the same kind of dividing line. The point is that among the metals that are marked here, there are metals that are quite brittle, which is what is marked in my table. In addition, standing after this dividing line are elements that are very ductile. And for example, the most ductile metal, gold, is in this block. Now I would like to say that not all elements of the periodic table are found equally, let's say, in nature. Among the elements that are in the periodic table, in terms of prevalence on our planet, on Earth, the most common element is oxygen. Silicon is second, then aluminum is third, iron is fourth, and so on. But if we are talking about outer space, then the most common element in outer space is hydrogen, as well as the element helium. Hydrogen in space accounts for about 75%, but on Earth its content is much lower, about 1%. For comparison, oxygen on Earth is 49% by mass fraction. Among the elements of the periodic table, there are record breakers, elements that have special statuses and special significance. If we are talking about the element that is the most active as a metal, or as we also sometimes say, the king among metals, it is certainly the element francium, named after the country of France. And the most active non-metal, the king among the non-metals, is fluorine. Even its name sounds like destroyer in Latin. If we're talking about which element is the most abundant on Earth, it's oxygen. The most common in space is hydrogen. The most expensive element in terms of performance, in terms of the cost of expenditure on it, is the element of California. But that does not mean that it is a very beautiful element, just that the cost of producing it is very, very high. In terms of the importance of elements to our body, the most important element is definitely carbon. Carbon is found in all living organisms, including our own, amongst others. According to the importance of location in our body, there are several such elements. Carbon is in first place, hydrogen, oxygen, nitrogen, phosphorus, sulfur, and some other elements. But organic substances are created by only a small number of elements. They are not more than 20, but metals enter the human body in small quantities. Their privilege is found mainly in the environment. In importance and in the use of metals, the most important metal for us is iron. Most of all kinds of metal structures use this metal to the greatest extent. Certainly important is aluminum. Without it, it is impossible to build any aircraft that flies with us. But from pure aluminum, of course, it is not made. Very many metals are joined together and accordingly alloys are obtained. That's why the alloy from which airplanes are created is called duralumin. If we are talking about alkali metals, these metals, as well as some alkaline earth metals, have a special precaution. They are stored specifically in a closed container because they are not just alkali-forming metals, but they react very violently with water. I highly recommend that you watch experiments like this that show their interaction. That's why these metals try to be stored in a closed form. And the importance of the elements of the Mendeleev table is extremely high. Many of them are more actively used by humans. Some of them are perhaps less active. But I would like to add the following at the end. The discovery of the periodic law and the periodic table to predict what properties certain undiscovered elements would have. And the merit of Mendeleev, a Russian scientist, is that three elements, scandium, is the element gallium and also the element germanium. These three elements were predicted by Mendeleev so accurately that when they were 15 years earlier predicted by Mendeleev and then discovered, Mendeleev's prediction was a very high percentage, on the order of 95% on the whole characterization of properties. So the Mendeleev table has an unqualified merit in that you can predict what properties certain elements of the periodic table will have, even without having yet obtained such an element at all. So now the development of the Mendeleev table goes on and on. and the elements that are already in the 8th period, they are being researched. But the only thing is that beyond the 90th order number, these elements are practically not found in nature, and they are synthesized. Therefore, their occurrence is practically zero in nature. They are obtained by radioactive synthesis or nuclear reactions. This is how the periodic table is arranged in an unusual way. It inspires many scientists of different subjects to work with it, predict some properties, use them in medicine, and so on. Therefore, this is a unique creation that we have in chemistry. And thanks to Mendeleev, we can use such a table in our lessons and use it in everyday life. This is the most popular table that you can find, including on the internet. That's all for today. Goodbye.